Proportionality theorems. First of all, triangle proportionality theorem. It says that if this line, TU, parallels the bottom line of the triangle QS, let's call it the bottom line, and then it bisects the other two sides of the triangle. And because they are parallel, and that's really important, it cuts the two sides proportionally. Okay, it cuts the two sides proportionally right here. So if you look at this triangle here, it's RT over TQ equals RU over US. So these sides, in other words, are corresponding to each other. Right there. Converse of the triangle proportionality theorem says that if a line divides two sides of a triangle proportionally, meaning RT over TQ, TQ would be here, should equal RU over RS, right? If these two ratios are equal to each other, meaning the two sides are proportional, then this line is parallel to the third line, meaning TU is parallel to QS. So let's see how we use it. In the diagram, QS is parallel to UT. It's right here. And RQ is 10, RS is 12, ST is 6, and what is the length of QU? So all we really need to do, because we know that they are parallel, we just need to find the ratios. So by triangle proportionality theorem, RQ over QU has to equal RS over ST on this side. That's by triangle proportionality theorem. And then if we substitute what we already know, do a little bit of cross products property. So I will have 60 equals 12 times QU. My QU would be 5. Right? Very useful, very simple, but very useful, somewhat intuitive. But the important thing is in the theorem is that the two lines have to parallel in order for you to draw the conclusion that it cuts the other two sides proportionally. Here's an example, aerodynamics. Doesn't that sound sophisticated? It says a spoiler for a remote control car is shown here with different dimensions. AB is 31, BC is 19, and CD, where CD is on top there. Okay, so in DE, I see. So if I have to take a risk and draw this two triangle, oops, told you I flunked my art classes at a young age. Let me try a different color with this one. The purple one would be B is here, D is here, and then C I will go use the blue again. Okay, so I've, you can ignore this part. That's just, oops, that's just bad drawing on my part. There we go. Not too bad. I'll just use this solid line. Sorry. Okay, so now we've got the picture. We've got AB to be 31. BC is 19. I totally did not draw the proportion right, but you got the concept. CD is 27 and DE is 23. Explain why BD is not parallel to AE. So really what it is asking is this proportionality here, right? So let's see, we just need to find the ratios. So CD over DE is 27 over 23. 23 is a prime number. There's nothing we can do. And then on the other side, we have CB over BA. That's 31 over 19, another bad number. We don't like these numbers because, you know, they're more challenging. And in this case, these two don't equal each other, and therefore BD is not parallel to segment AE. Okay? That's how we use the proportionality theorem of a triangle. Here's another theorem. If three parallel lines intersect two transversals, then they divide the transversals also proportionally. Basically, this is an extension of the triangle proportionality theorem. Frankly, if these two, eventually these two will meet, and that's how you create your triangle with different, how you, there we go. And you can see that you have really three triangles in there, ugly triangles, but you got the concept. And UW is right here over WY should equal to VX over XZ. Okay, and the next theorem says if a ray bisects an angle of a triangle, notice that it's now we're talking about angle bisector. So we're talking about angles, we're not talking about lines in this part. If a ray bisects an angle of a triangle and it divides the opposite into segments whose length are what to the length of the other two sides, meaning if I have AD over DB right here, AD over DB, what's the relationship to AC and BC? And really CA rather, they should be proportional as well. This one is less intuitive from our daily life, but it makes sense. You can actually prove it yourself when you get a minute, or you can come and see me and we can prove it together. Let's look at an example. Farming. A farmer's land is divided by a newly constructed interstate. Oh, don't you hate that? The distances shown here are in meters. Find the distance CA, which is right here. Find this distance between the north border and the south border on the farmer's land. What's given is that all three of the three lines, AF, BE, and CD are parallel to each other, right? So that's really critical information. So because they're parallel, we know that parallel lines divide the transversals, the two transversals proportionally. So in that case, CB over BA has to equal DE over EF. Okay, and now if I use property of proportions, I add the denominator into the numerator on both sides. DE plus EF over, over EF. Oops. Over EF. There we go. Just fixed it. And now I can use all the information given and just substitute it. So I should have CA over BA is 2000, right? And then DE plus DF is D, it's 3000 plus 2500 over EF is 2500. And then if I do my arithmetic cross multiply, you should do it on your calculator. You should come up with CA is 4400. So therefore the distance between the north border and the south border CA, the length of CA is 4400 meters. Okay, and here's another example. It's our last example. in the diagram, angle DEG is congruent to GEF. We like that. Congruent angles make life easier. Use given the side length to find the length of DG. Now, because we know that this is your angle bisector, EG is your angle bisector, and so now we can use the theorem we just learned. So we let GD, so if we do let GD equals X, because that's what we're asked to find out, then GF is 14 minus X, right? We need these two segments because of the because we need to find the proportionality. So now we know angle bisector divides opposite sides proportionally, so it's GF over GD equals EF over ED. Again, we can set this up because we know the angle bisector EG divides DF proportionally, and then you substitute all the information you have. Let's see if we can solve this. You cross multiply by cross product property, you should have 12x equals 112 minus 8x, and your x should come up to be 5.6. Okay, so basically those are all information that help you find which part of the triangle is corresponding to which part is proportional to which part, and once you get the information, the rest of it is just simple algebra. Okay, thank you guys.